Welcome to Driving Academy. Today we'll be looking at Cauchy-Riemann equation. How we want to use Cauchy-Riemann equation to dictate or show that a function is analytic. Now, today, Cauchy-Riemann says that the u for a function to be analytic, that your partial u over partial x must be equal to your partial v over partial y, and your partial u over partial v must be equal to your partial v over what? Over the x. He said that u here represents the real part of an imaginary function, the real part of a complex variable, and also your v represents the imaginary part of a complex variable. Let's use like say an example. So using the Cauchy-Riemann equation, show that the function f of z is analytic at all points, where f of z is equal to z squared. Let's look at this example. Now the question says that given that f of z is equal to z squared, and we said that z from the complex variable, z is equal to x plus what? Iy. Now, if we replace z, if we put z as x plus iy into this function here, our f of z will be equal to x plus iy all over square. Represents instead of z square, and we say z is equal to x plus iy. So we put x plus iy in place of z. So therefore, our f of z becomes x plus iy all is square. Now let's expand this. This will give us f of z equal to x plus iy in bracket into x plus iy. So this will give us x times x will give us x squared plus iy times x will give us xy. Then iy times x will give us plus ixy. Iy times iy will give us what? Plus I square will give us iy all in square. So this will give us x squared plus iy plus iy will give us i2xy. Now we are left with what? Iy all is square. If we open this bracket, this will give us plus I squared y squared, which is equal to our f of z. Now let's go again. Remember we said that I is equal to the root of minus 1. So therefore, I squared will be equal to the root of minus 1 all in square. So therefore, I squared is equal to what? Square will cancel this square root. We are left with what? Minus 1. So therefore, I squared is equal to minus 1. So in place we say I squared now, we're going to replace it with what? Minus 1. So therefore, our f of z will be equal to x squared plus i2xy plus, remember we said I squared becomes what? Minus 1. So minus 1 times y squared will becomes minus y squared. So this will give us f of z equal to x squared minus y squared plus i2xy plus i2xy. Now, we said that the u denotes the real part of the complex function, and the v denotes the imaginary part of the function of the complex function. So the real part is the part that doesn't have what? I as a coefficient, while the imaginary part is the part that has what? I as what? The coefficient. In this case now, the real part becomes u is equal to x squared minus y squared, and the imaginary part v becomes 2xy. The imaginary side that has the part that has I as a coefficient. So let's get, remember like Cauchy-Riemann said that the u dx is equal to the v dy. So let's get our du dx. Differentiate u now with respect to x. So therefore, if you differentiate u with respect to x, yeah, we're going to have differentiate x here, we're going to have what? 2x. Differentiate y here, remember when you differentiate with respect to x, y becomes what? A constant. And when you differentiate the constant, you have 0. So if you differentiate this, you have what? Minus what? 0. So instead of writing that as well, you can simply write what? 2x. So our dx is equal to what? 2x. Also, differentiate u with respect to y. Differentiate u with respect to y. Our du over dy is equal to, differentiate x with respect to y here is 0 because it becomes a constant. Differentiate y here, we are going to have what? Minus 2y. So therefore, du dx is equal to 2x and du dy is equal to minus 2y. Also, let's go to v here. Differentiate v with respect to x. We have dv dx is equal to, differentiate this with respect to x. Differentiate x here, you have y. 1 times 2 times y becomes 2y. So dv dx is equal to 2y. Differentiate v with respect to y, which is dv divided by dy. We have differentiate y here, we have 1 times 2x, it becomes what? 2x. So here it becomes 2x. Remember that when you are differentiating with respect to y, x becomes a constant. And when you are differentiating with respect to x, y becomes what? A constant. So if you differentiate v with respect to x, you have 2y. And differentiate v with respect to y, you have what? 2x. So let's check if this our function is analytic using the Cauchy-Riemann equation. Remember that Cauchy-Riemann says that du dx is equal to dv dy, and du dv is equal to what? Du dy is equal to minus dv over dx. And let's check if our function here satisfies this Cauchy-Riemann condition. So what is our du dx? Our du dx becomes what? 2x. So therefore, du dx is equal to 2x. And also our dv dy. What's our dv dy? Our dv dy is equal to what? 2x. So dv dy equal to 2x. The first condition here is what? Satisfied. So let's check for the second one. Now, the second one says du dy must be equal to your minus dv over what? Dx. So what is our du dy? Our du dy is equal to minus 2y. So then it becomes minus 2y must be equal to minus dv dx. So minus dv dx is equal to 2y. So here it becomes minus, which is from the formula 2y. So therefore, f of z equal to z squared equal to x squared minus y squared plus ix plus 2 plus i2xy here is an analytic function. Because it satisfies the Cauchy-Riemann equation. So, since 2x is equal to du dx is equal to dv dy, and your du dy is equal to your minus dv over dx, our function f of x equal to z squared equal to x squared minus y squared plus i2xy is what? An analytic function. So this is how you solve question on analytic function. Thank you.